This video shows another example in set operations after interpreting sets in set builder form. Welcome to Mathematics of Engineering. The problem gives four sets, one of which is the universal set, denoted as U. It covers all values of x, where x is a natural number, and it is from 1 to 18. The other set is A, which has all natural numbers from 1 to 10. The next set is set B, with natural numbers again, and it is computed as x squared, where n is between 0 and 5. The last set C again contains natural numbers, which are factors of 18. We are to look for first the intersection of sets A and C. Second is the complement of the union of sets A, B, and C. The third requirement is the intersection of sets A and B. Then, the symmetric difference of sets B and C. Then last is the difference of the intersection of sets A and C with B. Although it wasn't required, it is still easiest to identify the elements when we use a Venn diagram to visualize the location of each element. In the problem, we are to create three circles for sets A, B, and C. Then set U is drawn as a rectangle containing the circles. Having prepared all that we need, we can interpret each set. Start with set U, the universal set. It contains all values of x, and they should be natural numbers. A natural number is described as positive whole numbers, starting from 1 to positive infinity. The next condition of the set is x should be within 1 to 18. So U is with the elements from positive 1 to positive 18. Set A also includes all natural numbers from 1. The second condition is x should be within 1 and 10 inclusive. So set A contains elements from 1 to 10 in an interval of 1. Set B is again a collection of natural numbers, and this time, the next condition provides a formula stating x is the square of n, and n was limited from 0 to 5 exclusive. That means that n is equal to 1, 2, 3, and 4. Now we compute for x. With n equal to 1, x is computed as 1 squared, which is 1. With n equal to 2, x becomes 2 squared, and that is 4. With n equal to 3, x is taken as 3 squared, which gives 9. With n as 4, x is 4 squared, giving 16. Thus, the elements for set B are 1, 4, 9, and 16. The last set is C, which is yet another natural number. So we expect a positive whole number. Eggs are factors of 18, which can be identified as factors 1 and 18, 2 and 9, and also 3 and 6. Thus, set C has elements 1, 2, 3, 6, 9, and 18. The next step is to summarize all elements from each set to be able to distribute them in the Venn diagram. So set U has elements from 1 to 18. Set A with 1 to 10. Then set B has elements 1, 4, 9, and 16. Then set C has 1, 2, 3, 6, 9, and 18. Now, we locate the position of each element in the diagram. Starting from 1, we can find this element in all the 4 sets. So that would mean that 1 is in the intersection of all sets. Next is 2, which can be found in set U, set A, and set C. Since U is the universal set, that means that 2 is inside the rectangle. And again, it is common in sets A and C. Next is 3, which can be found in sets U, A, and C. Just like 2, 3 is placed in the overlap of sets A and C. For 4, we can find it common to sets U, A, and B. So it should be placed in the overlap of sets A and B. 5 is found in sets U and A, so it should be positioned at this location. For element 6, it is over sets U, A, and C. So it should be located in the set AC overlap together with 2 and 3. 7 is also found only in set A, which is a subset of the universal set, so it should be placed at this part of the diagram. Same with 7, 8 is also found only in set A. Next is 9, and this element can be seen in all the sets, which means we can place it in the overall intersection of the 3 sets. 10 is again found only in set A, so it would be with elements 5, 7, and 8. 11 is only found in set U, so that means it is not inside any of the circles. This is also true with 12. There is also 13, which is outside the circles. 14 is the same, and also element 15. For element 16, this is found in sets U and B, so it should be in a circle, and that circle is set B. Again, element 17 cannot be found in any other set except set U, so it would be together with those outside the circles. Then the last element 18 can be found in both sets U and C, so it would be placed in set C, free from any overlaps. Now that all elements are placed in their respective locations, we can start identifying the elements in the operations. First is to identify the elements in the intersection of sets A and C. So from the Venn diagram, that would be their overlap, showing elements 1, 2, 3, 6, and 9. The next requirement is to identify elements included in the complement of the union of sets A, B, and C. With most of the elements included in the circles, the complement are those not in any of the circles, being 11, 12, 13, 14, 15, and 17. The third requirement is the elements in the intersection of sets A and B. They are elements 1, 4, and 9. The next requirement is for the symmetric difference of sets B and C. By definition, symmetric difference is the union of the two sets B minus C and C minus B. Practically, this means the union of the two sets except their intersection, giving elements 2, 3, 6, and 16 from set C, and 4, and 18 from set B. The last requirement calls for the difference of the intersection of sets A and C with B. So let's highlight the intersection of A and C again. It contains the elements 1, 2, 3, 6, and 9. Then we remove those elements included in set B. So the remaining elements are 2, 3, and 6.